Hello, my name is Kyle Amon, and I am currently a senior in the Engineering Design Technology program here at Pennsylvania College of Technology. The following is a short presentation of my senior capstone project proposal. My senior capstone project will be the creation of a new auto belay system, a system that can be halted by the user anywhere on the wall. To understand what an auto belay is, you must first understand what the term belaying is. Typically, when someone wants to climb a climbing route in a gym higher than 13 feet, they need a few things: two people, two harnesses, a belay device, and a dynamic rope. An auto belay system removes the need for a second person and replaces it with an automatic braking force that lowers the climber to the ground in a slow, consistent manner. This is me 2 years ago getting a taste of my first auto belay system experience. Think of a large seatbelt. I free fall for one quick moment until the system starts to brake on its own. Currently, all of the auto belay systems on the market have one main issue that I see. Once you start climbing, the only brake you get is the one enabled by your free fall that slowly lowers the user to the ground. There is currently no way to stop on the wall without relying on the user's own strength and holding them onto the wall. The other main problem is price, which can be broken down into initial cost and upkeep. Most name brand systems cost thousands of dollars to purchase and require costly inspections yearly to ensure safety. My proposed solution is to create a system that can stop the climber on command while not breaking the bank. A system with these two features can be applied to many businesses, as COVID has caused many shutdowns of climbing gyms across the country and world. There are two major companies who produce gym-friendly auto belay systems, True Blue and Perfect Descent. The design of these two systems is what I have decided to produce my final project around. I have also decided to use electromagnetic braking as my preferred braking system. Here is a short video explaining how electromagnetic braking works.
Participation and reduce costs. The technology inside many of our devices is eddy current magnetic braking. Eddy currents are forces that occur when non-magnetic metals move through magnetic fields. There is no reaction when the two objects are still, but when motion is introduced, eddy currents are created. These eddy currents oppose the magnetic field, and it's the opposition of these two forces that creates the braking effect. In our devices, when the webbing is pulled out by a participant's weight, centrifugal force sends aluminum rotor arms spinning past stationary magnets within the device. This movement creates the eddy currents within the aluminum arms. The force of these eddy currents oppose the force of the magnetic field, therefore braking and slowing the release of webbing from the device. There are many benefits to eddy current magnetic braking. Low maintenance. Because the braking is magnetic, there are no contacting parts like brake pads that will wear out or fail. That means less maintenance and a low cost of ownership. Self-regulating. The braking resistance automatically adjusts to provide consistent braking across a wide range of participant weights. Children and adults alike will enjoy a similar experience. Smooth and comfortable. Whether jumping, descending, or approaching a platform, the experience is always smooth and easy.
To get a better understanding of what is inside the system, I have two diagrams showing the inner workings of the system. You can see in figure 9 and 10 how the eddy current will be engaged as the aluminum rotor arms spin with centrifugal force as the rope is pulled out of the system. I will use my knowledge of 3D modeling to design, to the best of my ability, models and assemblies of all components inside the auto belay system. I will then produce rendered images to show off the final project. I will then take those 3D models and produce 2D detailed drawings of each individual component. I will also create an exploded assembly animation to show the connection points of all individual components, as well as an exploded detailed drawing of an assembly with a build of materials. After the completion of the assembly, I will take my knowledge from DSG 421 to render a simulation of how the assembly will react when the load is applied to stop the climber at a desired height. Another simulation will be run to show off the assembly and how it reacts when the climber decides to continue climbing. With rapid prototyping, additive manufacturing has always been a favorite of mine. This image shows a flash drive I had made when I was a junior in high school. With the knowledge I have learned at Penn College and my internship at the Department of Defense, I will be producing a working prototype of ABS plastic on fusion deposition modeling printer, with some parts being possibly printed on a stereolithography apparatus printer. If some funds are secured for this project, I would like to get parts machined here at the college by friends of mine who are seniors in the manufacturing engineering technology major. Finite element analysis will be run on heavily stressed parts, such as the carabiner that secures the climber to an autoblade system. A price calculation will continually be updated as steps in the process become complete. In conclusion, I think the product will fill a gap in the current market. My final product will be an innovation of what is already available, but will give users a new idea of what an autoblade system should come standard with. The project itself will allow me to showcase in my e-portfolio a broad range of different skills that I have learned here at Pennsylvania College of Technology. If you're wondering what this video is at the end, this is speed climbing with the perfect descent autoblade system. You can see that the lanyard has no slack, which is unconventional compared to when you have a two-person belay system.